you have. So let's talk about a few concepts that we discussed and they're extremely important. So we have a function. I just created this this afternoon. So we have a function which is secant squared x. We're asked to find three different things. Find the derivative, the differential, and the antiderivative. Can anyone tell us how to write from starting with the notation, everything? Starting with the notation, what do I have to write for the derivative? Anyone?
dy dx.
Yes, we can write dy over dx, perfect. But we also want to see this, perfect. And what will that be?
Secant tangent squared.
Careful. It has power 2. I have to start with the outermost.
Oh, you're right. Two secant.
2 secant x times the inner function prime.
Secant tangent.
Awesome. Allow me to put this. That's it. Awesome. Perfect. Now the differential starting with the notation. For the same function, of course.
It's dy equals.
Good.
I think it's the derivative times dx.
Excellent. 2 secant squared x times tangent x dx. Awesome. Perfect. Now the antiderivative. Notation first. So we had f of x, and now we want the notation.
Capital F.
Perfect. And I should have mentioned most general. That's what I want. There is no given condition. It's clear. If there is no given condition, then we are always asked to find the most general, but I want to be specific. Can anyone tell us what this is?
Tangent x plus e.
Perfect. Awesome. Great. Thank you very much. If c prime is given, what does c of x plus d represent? So this is the marginal cost, the derivative of the cost. What will this represent? What will c of x plus d be?
The cost at a specific
Yes,
amount.
yes, because I did not specify. This will be the most general antiderivative of the derivative, right? So the most general antiderivative of c prime of x. Perfect. Now you're way ahead of me. This is the question that is next, exactly what you just said. If we're given the marginal profit, but we are not given it, we're given it in the form of a graph, what will this area represent? What is this?
Would it represent the total?
Yes,
total profit?
yes. So this is the total profit exactly between 0 and 10, if this is measured in years, on 0, 10 years. Awesome. We can only determine the limit of the Riemann sum for blah, blah, blah functions. Specifically, what type of functions we can determine the limit of? We are very restricted, very limited. We can only determine the limit of the Riemann sum only for specific functions, only one group, specifically from that group.
Is it quadratic?
Quadratic.
Linear and cubic?
Awesome. What are they called, all these three together?
Polynomials?
Polynomial functions indeed. So we can only determine the limit of the Riemann sum. We are limited to polynomial functions. Specifically, only these three. Degree 1, degree 2, degree 3. Awesome, thank you. Last one.
Why can we not use the Riemann sum on fourth degree polynomials, for example?
Because we don't have the sum of I to the fourth.
Okay, that makes sense.
So now the last one, we only have the sum of 1, we have the sum of I, we have the sum of I squared, and we have the sum of I cubed. This will be beyond control. Okay, last one. The area determined with blah, blah, blah subintervals is exact or approximate.
It's exact.
With blah, blah, blah subintervals. Careful.
N subintervals.
N subintervals. If I use N subintervals, like N equals 4 or 16 or 32, the area will be exact or approximate.
Exact. Oh, oops.
That's okay. When
How is it?
Hold on. Hold your question for a second. When N approaches
infinity,
right? So we use that. The area is
exact.
Yes. So you answered your own question. So if we only are restricted to a specific number of subintervals, 2, 4, whatever, then it's an approximate. But when we take that N to infinity, of course in a limit form, when we take that N to infinity, then the area is exact. Good. The floor is open for any questions, anything you like to say, anything you want to work on, anything.
I was wondering if we could do the Riemann sum question that was on the written homework.
Yes, I don't remember. I didn't write the solutions yet. I'm sorry. I graded all weekend long. Sorry. Can you remind me the function and the interval?
Yeah, just 1 second.
I can look it up too.
It was it's 3x squared plus 4x plus 2 on the interval 0 to 4.
And 3x squared plus 4x plus
2.
Plus 2. Perfect. Thank you so much. Okay. So I know we only had one situation, and this is another one, so we can create other functions, of course. So whenever we want to determine the limit, we should always write that the area is exact as the limit as n approaches infinity. It's wise to put delta x already outside f of xi from I equals 1 through n. So this is the formula we have to use. It has 3 preps. This is the best way to start. First of all, I have to have delta x, which is b minus a over n. So that's my first prep. My second prep has to be xi, which by definition has to be this. So if the interval is a comma b, xi will always be a plus I delta x, always. So then in our case, xi will be 0 plus I this. So it's only 4i over n. And in step 3, I have to find f of xi, which is this piece right here. All I have to do is plug this in. So f of 4i over n, plug it in the function. There is not enough room here. So let me move on. Page 3. So that will be 3 times 4i over n squared plus 4 times 4i over n and plus 2. From this moment on, it's just plain algebra, right? So 4 squared is 16. 16 times 3, 48. I squared over n squared plus 16i over n and plus 2. I'm checking my numbers again. So 16 times 3 is still 48. Yes. Now, finally, I have to put all this information in the area formula. Limit n approaches infinity. I have delta x, which is 4 over n. the sum from I equals 1 through n from this. 48i squared over n squared plus 16i over n and plus 2. Now I'm using a property of the summation notation or sigma notation. The summation of 3 terms is the summation of the first plus summation of the second plus summation of the third. I have to write that. So limit as n approaches infinity, 4 over n. When I put the sum in front of this term, I realize that 48 over n squared can go outside, and then I have summation of I squared. When I put the sum in front of this, I realize that 16 over n does not depend on I. It's a factor, it can go outside. Plus, this is 2 times 1. So 2 is outside the sum of 1. Now I know the formulas for all these 3. This is the ugliest one because it's n plus 1, 2n plus 1 over 6. This is the nicest because it's n. This is okay. n plus 1 divided by 2. So at this point, the next level, the next step, the summation notation will go away. We will get replaced. The first one by all this, the second one by this, and the last one by n. Okay, next. Any questions? Let's stop for a moment. Maybe you have any questions for me here. Are these steps clear so far?
What did you multiply 2 by on the last?
So
2 times 1.
So we only have the sum of 1,
Yeah.
sum of I squared, sum of I cubed.
Yeah.
So 2 can be written as 2 times 1 because only 1 can be replaced by this.
Yeah.
So then 2 is a factor that stays outside, and the sum of 1 is here.
Okay, sounds good.
Better?
Yep.
Perfect. So then we
And,
have.
sorry, one more time. Under each I'm confused about this. Under each summation symbol, we have I equals 1.
Oh yeah, of course.
And I'm just confused. If I equals 1 and we're like writing that down, why don't we just like, isn't I squared just 1? Why do we have to write out n plus 1, 2n plus 1 over plus 1 over 6? Because wouldn't it just be summation of 1? Because I equals 1.
I equals 1 through n. I is not 1. I is not 1. 1 is the lower limit of the summation.
Oh, okay. That makes sense, actually.
So for example, this one means when I is 1, I have 1. Then the sum says plus. When I is 2, I have 2. Plus. The sum says plus. When I is 3, I have 3, but I have to get to the last one. I have infinitely many terms. So the summation replaces infinitely, well, it's finite, but a huge number of terms. It's not, it says from I equals 1 through infinity. So there are infinite terms, but here, this is just from I equals 1 through n, and then we will let n go to infinity. So this is replaced according to the formula. The sum of I squared, it has to be replaced by this. Replacing it by this, we take care of all the terms. Okay? I meant to write n here. Then we will take n to infinity. So it's n, of course. So from I equals 1 through n, this piece can be replaced by this formula, according to what we discussed last time. We didn't prove them. If you want, we can prove them. Hopefully after class, if you want to stay, I can prove any of these for you, if you want. Or if you have time, we have time during class as well. Doesn't matter. So these are the formulas that we have to use. If we have the sum from I equals 1 through n, from I cubed, we have to replace it by this, and so on and so forth. Is this better?
Yes, that makes sense. Thank you.
Thank you. Good. Where are we now? Okay, so limit Sn. Don't stop. Don't wait for me to stop and ask if there are questions. Please. There isn't. I want you to interrupt if you have questions. Okay, let's put it that way. Easy. So 48 over n squared. And I will always distribute here. Always. It's always easier if you do that. 2n squared plus 3n plus 1. You will never be able to simplify these. So always multiply them before you. We cut back on a little bit on writing because this will be 3 pages long, right? If we can, of course. So plus 16 over n times. Don't multiply those. Only here, these two. Over 2 and plus 2n. So let's see if we can simplify something, but careful, we still have to have an n in the denominator. So I can simplify, let me use a different color, that's better. So I can simplify just one of these two, this one. Do not simplify the n here, there is no point. You can simplify the factor, but not the n. Okay, so then I have limit as n approaches infinity, 4 over n in front. The least common denominator still has to be n. This one does not have a denominator, which means it has denominator 1, so it always has to be multiplied by n. So 8 distributed here. So 16 n squared plus 24n and plus 8. 8 distributed here, 8n times n, and 8n times 8, and then plus 2n squared. And of course divided by n. So let's go through these one more time just to make sure I didn't forget anything. So 16, 24, and 8, that's correct. 8n times n, 8n squared. 8n times 1 is 8n, and 2n times n is 2n squared. Again, just algebra now. Combine like terms, multiply. So I'm going to put a triangle here, and I'm on page 4. Stop me if you have questions, please. Let me see the time here. I'm okay. So limit as n approaches infinity. N squared now. 4. And let's see. This is a 10.
Can you slow down a little bit and move the paper down? Thank you.
Also remember, I will post this after class, just in case. So 16 plus 10, 26. And then we have 24 plus 8, which is 32. And then plus 8.
For 2 steps above that, for where you factored out the, I thought it was n plus 1 to 2n and 2n minus 1 over 6, not 2n plus 1.
That's not possible. If we are adding everything and there are positive terms, how can I ever have a negative?
Oh, yeah. Okay, that makes sense. I must have written that.
No worries, no worries. We clarify everything in class. That's the best way.
Yeah.
Awesome. Okay, other questions here before we continue?